Okay, so hi guys. What I want to do in this video is I want to go ahead and give you an introduction to what Pascal's triangle says. So if you're in Algebra 2, you learn about this when you learn about the binomial theorem. Or if you learn it in pre-calculus as well. I cannot remember what class exactly they teach this in, but you know, this really is connected to the binomial theorem if you think about it. But the main, I first want to introduce what Pascal's triangle is and why, what is the point of, why do we use it? So, Pascal's triangle is a method that, that mathematicians use when they for example, like a plus b squared, quantity squared, and we would do the box, and we would say this is, a plus b, and then this is a plus b, so we would say a squared, ab, b squared, and then we would just add up a squared plus ab plus b squared. We would say a squared plus 2ab plus b squared. Well, with Pascal's triangle, the reason why you would do Pascal's triangle is so that you don't have to be doing this, so that you're not doing this for every, as the binomial gets larger and larger. So for example, if we had something like a plus b to the 10th, a plus b to the 5th, etc., that is exactly why people use, or why mathematicians use Pascal's triangle, So I want to introduce this concept to you guys, and it is important because it really ties into the binomial theorem. And what the binomial theorem is that it's a binomial that, it's a whole theorem that you would prove, which I'm not going to go into that because I don't really know how to prove it, but I do know that it has to do with expansion of binomials. So, the way that they would do it is they would say, okay, if we have, for example, let's just say we have our first or our 0th term, and we start with a 0 because, when we say a plus b to the nth power, we want numbers, we want to start with the term, the nth term, that where n is greater than or equal to 0. So basically that is exactly why they start with the 0th term. That means that a plus b to the 0, for example, that's our 0th term, so we would say, to the 0 power, and so this would be 1, and that's how they would do it. And now when we go to the first term, we would say, well, this is just a plus b to the first power. That's just a plus b. However, if you have seen how the Pascal's triangle looks, you would see that there are ones just, there are multiple numbers of 1 just, put on, they kind of make like a tree or like a triangle kind of, So the way that I would do this, and the way that they, the way that they would teach you this is they would say, okay, well, this is a plus b, so that means that for the coefficient of a, which is the very front number of a, because I have 1a, that's just 1, so we're just going to say this is 1. And for b, it's 1 as well, so we would say, okay, this is 1. And then from there, they would say, okay, what's the second term? The second term, you would say, well, this would be a squared plus 2ab plus b squared, right? Of course, because it's not really as easy to remember that, the way that they would put it is they would say, okay, well, this is, as we go down the line, as we go down the triangle, we would add more 1s as we go along. So we would say like this, and then we would kind of keep going on and on and on until we get to, kind of, basically this goes on forever. But my point in this is that they use this to find the nth term, meaning that, for example, if I wanted to find a plus b to the 6th power, I would have to do this until I get to 6. So, for this part here, I would say, okay, well, this is, we would start with 1, and then we have 1 and 1. So then, right here, we would say, now, this is 1, and what I'm going to do is I'm going to add these two numbers here. So these two numbers, I'm going to say that's 2, right? And then from there, I'm just going to keep going. I'm going to say so basically, I would say this is why we have a 1a squared, a 2, and a 1b squared. That's 1, 2, 1. That's kind of how it works. So now as I go down the line, I say, okay, well, now for the third term, what would be for the third term? So basically I would say, oh, the coefficients are going to be 1, and then we have a 1 and a 2 here. We're going to add them together. So we have a 3, a 2 and a 1. We're going to add those two. That's a 3, and then we have another 1 right here. Okay, so that's going to be the a cubed plus, and I honestly, to be honest with you guys, this is kind of a difficult thing to do, because the thing is that, I know how to do the coefficients. Unfortunately, I'm still trying to figure out how to do the variables. So give me 1 second. Okay, so, the main pattern for this, so now, okay, so here's the thing about Pascal's Triangle. Give me a second. Where was I? Sorry guys, hold on. Okay, so the main idea with this, now it's very difficult, it's not difficult to explain, it's just really, for me, it still takes kind of a little bit to explain this. Basically, when you have any type of nth term, what you're gonna do is you're going to, every time you go, so for example, let's look at this one here, a plus b cubed. If we look at a plus b cubed, so basically what's happening is that we're going, so basically we have a cubed, and then we're gonna go ahead and we're gonna decrease it by 1. Okay, so we're gonna say a to the 3 minus 1, b to the nth power, meaning that, basically because apparently, that's just kind of how it is. Now, actually, hold on, it's not b to the nth power, it would be b to the first power, so it would be b to the first power. And then as you keep going, you're gonna keep decreasing by, with a, you're gonna decrease by 1. You're gonna decrease the exponent by 1. So basically you're gonna say, you have a cubed plus a to the 3 minus 1, b to the first, and then you're gonna say plus, I think it's going to be plus, you're gonna say a to the 2 minus 1 b squared plus a to the first b, and then b cubed, actually, and then that would be how you would do it, and then plus a to the 0th, or sorry, it would be a to the 1 minus 1, sorry about that guys, because you're decreasing by 1 each time, so you would say 2 minus 1, and then you would say 1 minus 1 b cubed, and then that would be the final term, because you can't go lower. Basically, you're gonna have a cubed plus a squared b plus plus ab squared plus a to the 0th power b cubed, and that will give you a cubed plus a squared b plus ab squared plus b cubed. Now, basically what I am trying to say with this is that whatever nth term you have, notice that we are decreasing the exponent of a each time as we go, and with b, we're increasing it by 1. That is the pattern here. That is what we're doing. And we use Pascal's triangle to kind of guide us in terms of what coefficients would we have in terms of what term we're trying to get to. So we're going to do one example where we actually use Pascal's triangle to actually, find the coefficients of, or actually to find the nth term of a binomial. So let's just say we have x plus y, and I'm going to say to the 6th power, okay? We're going to use Pascal's triangle. Now, you're going to start off with 1. You're going to say that this is 1, and then we have a 1 right here, right? And so we would then go ahead and keep going, so we would say 1, and then this part, this part right here, which I think it should be a little bit closer, it would be, we have 1 plus 1, right? So that's 2, and then we have another 1 right here. And then we would keep going. We would say, so basically this is x plus y to the 0th. This is x plus y to the 1st power. This is x plus y squared. And then we would say for the 3rd term, it would be a 1 right here. And then we're doing it, so basically think of it as kind of, you're kind of doing this, and you're basically adding each term, and then you're doing it for this one right here. You're going to or actually no, not this, but so basically you're adding every term that as you go down. So this one, you're adding these two, you're getting a 3, and these two, you're adding them together, you're getting a 3 as well, and then you put a 1 right here, okay? Now, going to the 4th term, you're gonna say another 1, okay? And you're adding these two, you're gonna get a 4. You're adding these two, you're gonna get a 6. Adding these two, you're gonna get a 4. And then you're gonna put another 1 right here. This is x plus y cubed. This is x plus y to the 4th power. And we want to get to x plus y to the 6th. So we're going to say, again, this is considered, so this is the 4th term. And then, and let me actually move it a little bit. Okay, so this is the 4th term, okay? Now, we're going to do the same thing we're doing. As we go down, we're adding, and we're putting another 1 right here. Anytime, the first thing that I would do as I go down is I would put 1s on each side, but I would put them before basically I would put them a little bit kind of like a tree, you're making kind of like a triangle. So basically, you have 1 plus 4, you're adding these together, you get a 5. 4 plus 6, you get a 10. I almost put 6. 6 plus 4, you get a 10. And then 4 plus 1, you get a 5. And then you get a 1. So then, this is x plus y to the 5th. These are the coefficients for x plus y to the 5th. And we want to get to the 6th power, so we're going to do it one more time. We have a 1 right here, another 1, and then we're going to put another 1 right here. We have 1 plus 5, that's going to be 6. 5 plus 10, that's going to be 15. 10 plus 10, that's going to be 20. 10 plus 5 is 15, and 5 plus 1 is 6. And then we have another 1 right here, so this is x plus y to the 6th power. Now, to know the powers or the exponents as you go along, you're going to start off, so basically x plus y to the 6 will be, basically you have x to the 6, because that's your first coefficient, right? And then, let's just make sure. Okay. And then for your second one, you have, you know, a 6, but remember that you have x to the 6, y to the 0th power. And then you're going to say plus 6x to the 5th, y to the 0 plus 1 power. Remember that you're doing 6 minus 1, and then you're doing y to the 0 plus 1 power. And then you're going to go ahead and do it for 15. So you're going to get 15 x to the 5 minus 1 power, and then y to the 1 plus 1 power. And this will all make sense once I actually, you know, I'll explain at the end once I actually get all the coefficients down. So then we have plus, and we're going to put our 20, so 20, and we're going to say x to the 4 minus 1 power, and then y to the 2 plus 1 power, and then plus 15 x to the 3 minus 1 power, y to the 3 plus 1 power. Okay, and then we're going to do it for 6, so plus 6 x to the 2 minus 1 power, y to the 4 plus 1 power, and then plus, you know, basically plus x to the 1 minus 1 power, y to the 5 plus 1 power. So once you kind of work all of this out, you're going to get x to the 6 times 1 plus 6x, 6 minus 1 is 5, so x to the 5th, y to the 0 plus 1, that's just y, plus 15 x to the 5 minus 1 power, that's x to the 4th, y to the 1 plus 1 power, that's y squared, plus 20 x to the 4 minus 1 power, that's x cubed, y to the 2 plus 1 power, that's y cubed, and then plus 15 x to the 3 minus 1 power, that's x squared, and then y to the 3 plus 1 power, that's y to the 4th, and then plus 6 x to the first power, which is just 6x, because 2 minus 1 is 1. So then, and then we have y to the 4 plus 1 power, that's y to the 5th, and then plus x to the 1 minus 1 power, that's x to the 0, and then y to the 5 plus 1 power, that's y to the 6. So then, looking at this, we're going to get x to the 6 plus 6x to the 5th y plus 15x to the 4th y squared plus 20x cubed y cubed plus 15x squared y to the 4th plus 6xy to the 5th plus y to the 6th. Basically 1 times y to the 6th, but it would be y to the 6th, you know. So if you look at this, this is our expanded binomial, right? And you can see, and I will explain exactly why we used this rule here. As you can see, every time we go down, you know, because we have x to the 6, that's what we start with. We're decreasing the exponent by 1. We're saying x to the 5th, x to the 4th, x cubed, x squared, x, and x to the 0. As we go on our y term, we go from 0, we get y to the 0, which is 1, y to the 1st, y to the 2nd, y cubed, y to the 4th, y to the 5th, and y to the 6th. And that's exactly what we're doing here. So I'm going to do one more example for this video because I really don't want to make it too long. So let's just say I want to do I'm gonna do a more easier one. I'm just gonna do x plus y. I'm gonna say x plus y to the fourth, okay? So I'm gonna start with 1, right? And then that's basically x plus y to 0, you know? And then we're gonna do, you know, x plus y to the first, that's just 1 for the x and 1 for the y. And then we're gonna do x plus y squared. X plus y squared is just, you know, we have a 1, and then 1 plus 1 is 2, and then we have another 1 right here. And then, you know, this is x plus y to the first, and then this is x plus y squared. And then for this part, we have a 1, and then we have 1 plus 2, that's 3. 2 plus 1 is 3. And then we have 1 right here. So this is x plus y cubed. And then we have 1 plus 3, that's, or actually, we're gonna put another 1 right here. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then we have another 1 right here. This is x plus y to the fourth. We're gonna do the exact same thing we've been doing. So, we're gonna start with x to the fourth, y to the 0th power. Now, I would recommend that you put your exponents or your coefficients in front so that you know exactly how to do it. And let me actually highlight these really quick. So as I'm going along, I'm going to be highlighting it. So basically I have 1x to the fourth y to the 0 plus 4x cubed y to the first. So we have a 4 here and then a 4 here. And then plus 6x squared y squared. So we have a 6 here, okay? And notice that I'm going down by 1 with x and up by 1 with y, plus 4x, and then it's going to be y cubed, because we're going up by 1, so it would be, 4 would be right here. We're going up by 1 with, we're going down by 1 with x and up by 1 with y, and then plus, and then we're going to say our last term, which is x to the 0th, y to the 4th, or it's just going to be 1 times y to the 4th, which is y to the 4th. So that's how it works. Now, we can say 1y to the 4th, just so that you guys can understand how it works. So basically, it works like this. Okay? And, that's basically how Pascal's triangle works. So our final answer would be x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. And this is our final answer. Okay. Okay, so I hope that helps, guys. I know that it was pretty challenging. You know, it was a challenging lesson, but it really just comes down to, you know, basically you just have to remember that the x terms, as you keep going, they decrease by 1 as you go on and on and on. And of course, I would recommend you guys that, you know, for those of you who are in algebra or who are doing this in whatever class you're in, please practice them over and over again. I know for me, it took a while to understand, but I understood it right away when I saw the pattern. It's basically a pattern is what it is. You have to find the pattern, and you have to kind of, you know, look at it and say, okay, you know, kind of just practice it over and over until you memorize the pattern. So, yeah, so I hope that helps, guys, and I will see you guys in the next video. Bye, guys.